held at Holiday Inn Select Montreal Centerville today. First of all, please allow me, on behalf of the organizers, to extend our warm welcome to all the attendees, both home and abroad, at this informative, exciting forum. Welcome and bienvenue. And now today we have a special guest, Dr. Moshe, chef and professor from Department of Pharmacology and Therapeutics at McGill University. Please join me in welcome Dr. Moshe, chef, give us the welcome message.
Welcome to the EPS Symposium here in Montreal. I come from the local university, McGill University, and I was asked by the organizers to welcome you and to tell you about the research that we're doing at McGill Medical School, and specifically, particularly our group. We here at McGill pioneered 2 decades ago the idea that DNA methylation, or epigenetics as it's called today, plays a very critical role in human disease. And for 20 years, we and others spent much time in understanding how DNA methylation is involved in cancer. And the idea was that although we inherit the genes from our ancestors, and there's something in genetics that will dictate our susceptibility to become sick or to be healthy, a lot of it is not in the sequence, but in the way the DNA is programmed during early life. And we introduced the revolutionary idea that DNA methylation could be programmed throughout life. So we have, on one hand, a fixed component that we inherited from our ancestors that we can do very little about, except document it, and a very flexible component in the DNA, which is the methylation machinery that marks and punctuates the DNA, and is highly attentive to what's going on in the world. So the idea was that what happens in cancer is that the signals that mark the DNA somehow mark the DNA in a way that it shifts from one program, which is its normal program, to a cancer program. Therefore, we suggested 25 years ago that DNA methylation therapy or interference with DNA methylation can play a very critical role in curing cancer. The first company in the world to work on DNA methylation pharmacologically was Methyl-Gene, which is here in Montreal as well, a few kilometers from here. Now the idea, as you know, has big fire. You can open a journal in cancer that doesn't have DNA methylation. DNA methylation therapies are now approved by the FDA, and newer therapies are evolving. The next step we went was to suggest that DNA methylation is not just involved in cancer, but is involved in other human disease. And around 10 years ago, a group of psychiatrists, psychologists, and ourselves have shown that DNA methylation could change also when social environments change. Because there's no difference really between chemical and social, because the social environment eventually goes to the brain and produces chemicals. And around 10 years ago, we showed that maternal care and the way the mother treats its infants in rats marks DNA methylation in the brain and affects their behavior throughout life. And that has led us to investigate whether DNA methylation changes might be involved in mental health problems in humans. And around 5 years ago, we showed that victims of child abuse, when you look at their brains, many years later, when they're deceased, around 35 or 40, this is what we look at, have marks of methylation, the changed expression of the glucocorticoid receptor in the hippocampus, and as a consequence, probably changed their behavior that led to the suicide of these victims that we look at. And that field, as you know, is growing in a logarithmic phase, because from all genetics areas, This is the area that carries tremendous promise, both pharmacologically, because finally we have something on DNA that we can control and change with pharmacology as well as with behavior, but also will have immense implications on molecular diagnosis, because now we can actually map the entire methylation of a cell, a sick person and a normal person, and get a landscape of how these marks are distributed on the DNA and identify with extremely high precision the state of that cancer or of that cell. Because now, rather than looking at one or a few markers, we can look simultaneously at thousands of markers that form a pattern, almost like your iris when you cross the border, and can recognize you without any distinction. DNA methylation forms a pattern across the gene that now technically is feasible to map and to arrive at a very exquisite picture of the state of the cell, and hopefully one day be able to predict, for example, who will get diabetes and who will develop mental health problems, so that intervention can be introduced very early. So this is kind of the work we're doing here. We're trying to combine many disciplines, from social sciences to the bench, from biochemistry to clinical medicine. It's a great university, and if you ever have an interest in collaboration or coming and visiting,